Okay, guys, for the purpose of this lesson, I want to accomplish two things. One, I want to review and recap exponential application problems, as well as remind you how to use the multi-view calculator. So let's talk about the two different types of application problems we have with exponential. So we have the growth and decay word problems, and we have compound interest word problems. With both of these, they still hold the form of f of x equals ab to the x. It just may be a little disguised. So for the growth and decay, we still have our a value, which is the initial amount, and then our b value is 1 plus the rate for a growth, or 1 minus the rate, a decay, still raised to x. Then we have compound interest. Again, it is disguised as ab to the x, where our initial value is called the principal, the amount we invest or borrow. Our b value is 1 plus the rate divided by the number of times it's compounded per year, raised to the value of n times t. So this is our x value. And remember, with compound interest, we're always talking about how many times it's compounded in a year. So t will always be in years, where over here, x can be minutes, seconds, months, weeks, years, whatever the word problem indicates. So let's get started. Jan invested $15,000 at a rate of 8% that was compounded quarterly. So here we go. Because it has compounded, we know we're going to use this formula. We're going to write an equation to represent how much money she will have over time. So let's identify the parts. Our principal is going to be the $15,000 that she invests. Our rate is 8%, but we're going to convert that to a decimal, which is 0.08. And then n, the number of times it's compounded, is quarterly. And the word quarterly means 4. There are 4 quarters in a year. Now let's write our equation. A equals 15,000 times 1 plus 0.08 divided by 4 raised to 4 times t. Now we can use our calculator, and we want to know how much money she'll make in 36 months. But remember, our t is time in years. So we have to convert. We can't just plug in 36 for t. We're going to have to plug in 3, because 36 months is the same as 3 years. So I'm just going to say this is 3 years. So let's go to our calculator. I have cleared it. To clear the calculator, it is going to be second, 0 for reset, and then I click 2 for yes. Now let's start, and we're going to plug in 15,000 times, I'm going to use parentheses, and then 1 plus, and now I'm going to use the N over D button and put in 0.08, and then arrow down and plug in 4, and then this arrow out, close parentheses, and then the caret button to raise it to an exponent, and it's going to be 4 times 3, or you could have put in 12, and then click enter. And so 4, so we have about $19,023.62. So let's write that here. So it's money, so we're going to write $19,023.63. That's how much she will have in 3 years. Now let's do it again, but this time we're going to plug in 10 years. So I'm just going to clear this, and we're going to do 15,000 times, again, 1 plus N over D. We have 0.08. We're going to arrow down. It was compounded quarterly, out, arrow out, close parentheses, raise to, I forgot how many years, 10 years. So we're going to say 10 times 4 and then enter. So this is how much she's going to have in 10 years. $33,120.59. Okay, so that's for compounded. Now let's go into another problem. This time it says Jan invested, again, $15,000 at a rate of 1.5% each month. Write an equation to represent how much she will have over time. So this is not compounded because our interest has not been compounded. We don't see that word. So we're going to use one of these equations. And since it's invested and it's going to grow, increase, okay, then we're going to use the 1 plus the R. So our A is 15,000, the initial amount. Our R is 1.5%. We're going to write that as a decimal point, 0.015. And the B value is going to be 1 plus the rate. So this is going to be 1.015. And X, it says, is months. So it's the rate is 1.5% each month. So when we plug in our number, we have to make sure it's in months. So our equation is going to be f of x equals 15,000 times 1.015 raised to the x, where x is the time that the word problem says. So it is months, and so the first go around we're going to do, it says 6 months, so we directly will plug in 6. So in your calculator, we're going to say 15,000 times 1.015 raised, so it's right here, raised, and it said 6 months. So we're going to do 6 months, and this is how much money that she will have. So this is going to be 16,401.65. Now the next time we plug in, we can't just plug in 1 for x because x is months, so we're going to plug in 12. Okay, so we're going to plug in 12 for x. So we have 15,000 times 1.015, and then that is raised to, and what do we say? 12. And this is how much money she will have in a year. So $17,934.27. So that's the difference between these two types. They're very similar, but this had the word compounded, so it told me to use this formula. This one did not. And when you invest and you earn money, or have you earn interest, your money's going to increase, so we had to use the growth equation. Okay, so this time, let's just go to this next one. The population at NFMS in 2010 was 12,000. It increased at a rate of 2.2, and this should be percent, guys, sorry about that. 2.2% each year. Write an equation to represent the population since 2010. So I don't have the word compounded, so we're going to use one of these equations. And since it increased, we're going to use 1 plus R. So A, the initial population was 1,200. Our rate is going to be 0.022. And so the B value is going to be 1 plus because we are increasing. So this gives us 1.022. So when we write the equation, we have 1,200 times 1.022 raised to the x, and x is years because it's a rate of 2.2% each year. So starting from 2010, the year 2010. So this time when we plug in, we're not going to plug in 2020 for X, we're going to plug in 10 because from 2010 to 2020 is 10 years. So this is like 10 years, and then we'll do 20 years. So let's go over here and let's clear. And we start out with 1,200 students. And then we multiply by 1.022 raised to 10. Let me start over. Sorry about that. Okay. 1,200 times 1.022 raised to the power of 10. And because we're talking about people, I'm going to round to the nearest whole number. So we have 1,492 people. Okay, and then we would do the same but plug in 20. Okay, let's see what else we have. The population of species T decreased at a rate of 4.5% each month. In January, there was a population of 18,000. So we're going to write an equation to represent the population since January. We're not going to use anything compounded, and we are using, it says decrease, so we're going to use 1 minus. So we have f of x equals our 18,000, and then it's going to be 1 minus 0.045 raised to the x, and x is representing is months. So we have 18,000, and then we're going to subtract. So we have 1 minus 0.045, and that gives us a B factor of 0.955 raised to the x. Now, from January to May, so we start out in January, and then we have February, March, April, May, and that's going to be 4. So I'm going to plug in 4. So this time, we're going to have 18,000 times 0.955 raised to, and we said 4. So that is going to give us, and again, we're talking about a population, so we're going to just round to the nearest whole number, 14,972. And then you do the same thing for September. You just count from January to September and plug that in for X. Okay, let's do one more. Grace invested $75,000 at a rate of 6% that compounded monthly. We're going to write an equation to represent how much she has over time. So since it said compound, we're going to use this formula. So A equals our principal of 75,000 times 1 plus our rate of 0.06, and it was compounded monthly, which means 12 months in a year, raised to 12 times T. And remember, T is in years. So we're going to see how much she's going to have in 20 years. So in our calculator, let's clear this. We're going to have 75,000 times 1 plus, and then use our N over D, 0.06, and then we arrow down, plug in 12, and then arrow out, and raise it to, and we wanted 20 years. So 20, and then it's times 12 for compounded monthly. And we're talking about money, so let's make it make sense. So this looks like $248,265.34. So hopefully this helps you with comparing the two different types of applications as well as using the multi-view calculator.